Hello and welcome to our special presentation and part of the Green Celebration of Education. I'm your host, Xavier Dexmay, with my co-host, Saad Youssef, and we're here today as members of the Bulldog Beat. The Bulldog Beat is a unique program designed to train students to become backpack reporters, news anchors, and video technicians. Bulldog Beat edits, shoots, and directs programs that air on RGC-TV, Channel 16.
Most of our community has been unaware of a fascinating piece of technology that has been displayed in our Center of Green for over 2 years now. The binary clock at Acme is a system ran by the binary code. Binary is a coding system that uses digits 0 and 1 to represent time with lights that reflect on certain columns and rows on the binary clock.
It is our mission to introduce this fundamental utility to the community so everyone can understand how to enjoy this one-of-a-kind feature at Acme Fresh Market in Greene, Ohio. Okay, Saad, so just a little background information on the binary clock. It was invented in 1969 by Dave Ulmer. It was made out of like little components, neon lamps, and it was housed in like a wooden case.
So the question that arises in our community is, what is the binary clock?
Yeah, we actually get that question a lot around here. But I think when we go pull up the picture, most people will be like, oh, because really it is something that we drive by every day not realizing it's a clock.
That's right. It's on the far left side of Acme in the silo.
Yes.
And I believe the general idea of this clock was presented by Steve Albrick. He was the former president of Acme. Now he's the vice president of the strategies department. His idea to build this binary clock in the center of town was to create a more fun and family-like environment for the whole community in their interactive store.
Yes, that's correct. And as you can see, it was built in a silo, right? Because as we know, Greene used to be a rural community. So it kind of gives off that impression of like a farm.
And I believe they got the idea from Back to the Future.
Yeah, that's correct. Yeah. He told us that he got the inspiration from the town clock in Back to the Future and how it represented a place for gathering. And that's kind of what he wanted for Acme's clock.
Let's have a quick look at the video from Back to the Future.
Okay. What a great movie to get inspiration from, you know?
That's right. Let's talk about the fun stuff and how the binary clock works and how to read it.
Okay, so the binary clock is actually pretty simple to read after you fully understand how it works. So instead of displaying numbers in base 10 like a normal clock, it uses base 2 to tell time using only ones and zeros. So since there are only 2 digits, lights can be used instead. On signifies a 1 and off means 0. So Acme's binary clock has 3 columns, as you can see. 1 column for the hour, 1 for the minutes, and a column for the seconds. The hour column is 1 row shorter than the rest because it only goes up to 5 rows while the other 2 go up to 6 rows.
Yes, and each row going upward represents a different numerical value. There's 6 rows, and the first row represents 1, and then it multiplies by 2 or is squared each time as it goes up. So the next row would be 2, 4, 8, 16, and 32. And as different LED lights light up on different columns, the sum of those lights of the numerical values add up to become the hour, the minutes, and the seconds on the clock.
For example, this clock has the 4th and 5th row lit up. So the numerical values are 16 and 8, which added together equals 24. So it's the 24th hour or 12 a.m. because, as you know, binary clocks are based on military time, so they tell time in 24 hours.
Now let's go into a few more examples, as you can follow on the screen with us.
Okay. So if we look at the first one we have, you see that rows 2 and 4 are lit up. So that would be the numerical value of 2 and 8. So add those together and you get 10 for the hours column. And then we go on to the minutes column, and you see rows 6, 5, and 2 are lit up. So that would be 32, 16, plus 2. So add those together and you get 50. Now the seconds column is actually pretty tricky to tell on an actual binary clock because it's telling seconds, so it just blinks like really fast. But if we look on this example, you see rows 4, 3, and 1 are lit up. So that would be 8 plus 4 plus 1, which equals 13.
Let's go into one more example, and then the last one we could leave so you could do it on your own. Let's start from the seconds. The numerical values of the first, the third, the fourth, and the sixth column is 32, 8, 4, and 1. You add those together and you get 45 seconds. Now to the minutes. The second, third, fourth, and fifth rows are shaded in, so the numerical values would be 2, 4, 8, and 16. If you add those together, you get 30 minutes. Lastly, the first and the second row are filled in. So 1 and 2 are the numerical values, which add up to 3 hours.
So the time would be 3:30 with 45 seconds.
Yes.
Okay, now there are a few differences between Acme's binary clock and the standard binary clock, this being the number of rows and columns and the way they're placed on the display.
On the standard binary clock, there's 6 columns instead of 3, like the one in Acme's silo. And there's only 4 rows instead of 6. And they follow the same pattern going upward, with the numerical values being squared or multiplied by 2 as they go up.
Yes, so, that's correct. Yes. Each place value gets its own column. So as you can see, the first column only goes up to 5 rows. Goes up to 2 rows. And the first minutes and seconds column only goes up to 3 rows.
And I believe Acme probably condensed theirs to add more space in the interior of the building rather than making a long clock outside in the silo.
Yeah, that's a good point. The reason why we're pointing out these differences is because if you were to look up what a binary clock would look like, yes, it's gonna look a little different than Acme's binary clock, because whoever designed it probably wanted to make sure that they could fit it all in that silo.
Yes, and I believe there's just to add in, there's a community room right underneath the clock.
Yeah, that's correct.
That
it's just like a gathering place,
yes,
for meetings and stuff.
Yeah.
Now, the binary clock is programmed by binary code, which makes sense. It's a coding system made up of rows consisting of a combination of 1s and 0s in an 8-digit sequence. 1s are like the lit up circles on the clock, while the 0s are like the non-lit up circles.
So they're like on and off switches, sending messages to the whole processor or system on to turn on certain lights or turn off certain lights. And I believe 8 of those digits together is called a byte.
Yes, that's correct. Just like how you would read a binary clock, binary code is very similar. With each slot going right to left, the values are doubled. The first digit from the right has a value of 1, the second is a 2, and then a 4, and so on, just like with the binary clock. You add the values of the 1s, and the 0s are assigned their correlating number, but those numbers are not exactly added. So then you would go to a binary conversion chart, and you take that numerical value, and you see which letter, number, or symbol it represents.
So now that we've learned a little bit about this binary code, let's go to an activity that we've prepared for you right after this short video.
This is the binary bracelets lesson. We are going to code our initials on a bracelet that we can wear
and show all our friends. You look good.
K and then C. So K has 8 digits.
Binary is a way of representing information using only 2 options. Sometimes people think of this as only 1s and 0s, but you can represent binary with combinations of on or off, up and down, in and out, or really any set of options.
Hi, I'm Orion, and I program robots here at PlayEye. All computers and robot brains at their most fundamental level are little electronic gates. And when the gate is open, electricity can flow through, and when it's closed, electricity can't. So an example of binary on the robot is the robot's eyes. The robot's eyes are LEDs, and those are lights that are either on or they're off. It's a binary system, one or the other. We can use the lights to represent binary numbers. So if we have a set of robots, we can say that the first robot is the ones place, the second robot is the twos place, the third robot is the fours place, and so on. And that's how you represent a binary number, and the robots will do it with their binary eyes and count it out for you.
Okay, so what we have here is we have some string, we got some beads, and we're going to pull up the reference sheet and kind of walk through the craft with you guys. So since my first initial is X and Saad's is S, we were going to go on the reference sheet and look at X and S and see what their binary codes are to determine what color beads they do.
So the binary byte for S is 0, 1, 0, 1, 0, 0, 1, 1. White is 1, 0 is the black bead. So my bracelet would be black, white, black, white, black, black, white, white.
And we would do the same thing for our last initials. And the final product will look somewhat like this. Just a normal black and white bracelet. It's a cool little craft to do.
This activity was brought to you by Codeorg, a nonprofit site dedicated to expanding the access to computer science and increasing participation in the computer science field.
And their vision is that every student and every school should have the opportunity to learn computer science just like they would with biology, chemistry, or algebra. The problem is that the majority of schools don't teach computer science.
I believe 40% of schools actually teach a programming or a computering class, while 90% of parents want their children to go into some type of programming or computering class.
Yeah, that's correct. And I know that Green High School alone actually only has 2 computer science classes. And I know that honors computer science is the only one that actually starts teaching Java coding. So you can see where the problem is there with the statistics.
And I believe computering is also the #1 source of wages in the United States as well.
That's right. 71% of all new jobs in STEM, technology, engineering, math, are in computing. But the problem is that only 8% of students who pursue a STEM job graduate in computer science.
And not only does it have lots of job openings, but I believe it has a 40% more earning than a college career.
Yes, that is correct. And last but not least, it's one of the more enjoyable subjects that we students like to learn. So as you can see, it's right up there with the arts and designing.
54%?
Yep.
The city of Green is a constantly developing structure that has enjoyed substantial growth over the last few years. Our hope is that this presentation has not only encouraged you to enjoy and use the binary clock at Acme, but in addition also to share your new knowledge with others in our community.
We also hope that the code we have introduced to you today has intrigued you and that will inspire you to learn more about the growing opportunities in the field of computer science. For more information on this worldwide movement to promote and spread computer science education in every school for every student, visit www.code.org.
And this concludes our special presentation on the binary clock. Many thanks to our studio audience who came to watch us live. Thank you to those of you who joined us today on GCTV Channel 16. The Bulldog Beat hopes we've succeeded our mission to captivate you with the latest insight on our community news.
This presentation was student filmed and edited and brought to you by the Bulldog Beat and Green Local Schools. Thanks again for watching, and as always,
Go Bulldogs!